EP. We're starting Unit 6, and this is Lesson 1A. Okay, we're going to have a review quickly of what you've learned in Proton. This will be on matter and atoms. Okay, matter is anything that has mass and takes up space, but is not energy. So I like this picture a lot. It's from Jumanji. The big elephant is crushing this car. Both the car and the elephant, they have mass and they're made of matter. Okay. Elephant has a lot of mass, a lot of kilograms in that elephant. Okay, the three types of matter. You should know this. I hope you do. Solid, liquid, and gas. Solid, liquid, and gas. And here are some examples. Oh, I see lots of different examples here. For solids, helicopter, submarine, a hammer. Liquid, cocoa, soup, beach water, juice. Gas, we have fire and evaporation. Lava, a gas smell, steam from the grill when you're cooking. Okay, matter is made of atoms. So on the left you have a block of wood. That wood is made of atoms, and those atoms have parts, and we have three different parts in an atom. So this would be carbon atoms, and the atom can be broken down into three different parts. So an atom is the smallest part of an element. And the parts of an atom are, well, in the center we call it the nucleus. And the nucleus has two parts, one is protons and the other is neutrons. And then spinning around the nucleus in orbits we have electrons. So the protons, they have a positive charge, and the electrons have a negative charge, and they keep each other away. So what is an element? So this is the periodic table of the elements. You'll all be getting a copy of this in class. So an element is matter that is made of only one kind of atom. And so when we look at the picture, we see three different squares. These are element squares, and the information in each square tells us about the element. The different numbers of protons and neutrons make different elements. So when you look at, let's say we're looking at the square for oxygen, the number above the O is 8, which is its atomic number. Tells us that there are 8 protons. And the number at the bottom is the number of protons and the number of neutrons. It's called the atomic weight. That is 16. So the atomic weight is 16 for oxygen, one atom of oxygen, and the atomic weight for iron is 55.9, almost 56. So iron is a lot heavier. And then we have Pb, which is lead, and the atomic weight is 207. So lead is very heavy compared to oxygen. Pictures. In the pictures we have calcium, gold, hydrogen, iodine, silicon, copper, sulfur, carbon, and mercury. Okay, let's move on to chemical formulas. So this picture is a compound, and it's glucose, C6H12O6. So if you count the carbon atoms, there's 6. When you count the oxygen atoms, there's 6. When you count the hydrogen atoms, there are 12. C6H12O6. So chemical formulas. A molecule is a group of atoms joined together. H2, O2, N2. All right. A compound is a substance with more than one type of atom joined together. So the compound can also be a molecule. Okay. And let's see. let's talk more about parts of a chemical formula. So we have something called a subscript. It shows the number of atoms of that element. So the example one, it is C3H8, which is propane. It has 3 carbon atoms and 8 hydrogen atoms. If an element symbol does not have a subscript, it is 1. So example 2 is like that. It's HCl, hydrochloric acid. It's only 1 hydrogen atom and 1 chlorine atom. More on chemical formulas. Example 3, NaCl, sodium chloride. Na, there's 1 atom of sodium. Chlorine, there's 1 atom of chlorine. Example 4, iron oxide, FeO3. So there is 1 iron atom and 3 oxygen atoms. In lab, we will make many molecules using molecule kits. They're little plastic balls that stick together, that are snapped together with plastic sticks. So on the left, it's H2, hydrogen as a gas, and on the right, it's water, H2O. Okay, changing materials. So in the picture you see baking soda and vinegar. And if you've ever made a volcano and had the lava come spewing out the top for a science experiment, you've combined vinegar and baking soda to get this chemical reaction that produces a lot of bubbles. The bubbles are from carbon dioxide. So we have physical changes. A change in which no new substance is made. A change of state, like boiling water, is a physical change. Physical changes are reversible, which means you can get it back again. A reversible change, something that can be changed back to how it was before. Here's a little cartoon picture. In a physical change, you can potentially, that means possibly, undo the change by putting things back together. You'll notice that the boy has cut all of his hair off and she wants to glue it back on. Okay, well, yeah, you can do this. The physical change is that the hair was cut. Chemical change, a change that makes a new substance. Many chemical changes are irreversible. They cannot be changed back. Irreversible changes, something that cannot be changed back to how it was before. The picture on the left is a reaction between iron in the car and oxygen. Okay? Rust is formed. Iron oxide. And the match is burning. Carbon dioxide is being released, carbon into the air. And the picture on the right, fireworks exploding. These are all examples of chemical changes. We cannot change them back to the way they were before. So physical change or chemical change. Is the boiling water physical or chemical? Is it a physical change or a chemical change? Boiling water is a physical change. Fresh lemonade, a physical change. Baking a cake. Think about what you start with. It is a chemical change. Mowing the lawn. That is a physical change. Fireworks. Chemical change. Digesting food. A chemical change. A chemical reaction is a change that makes a new substance. So we start with an egg and we fry the egg, and this is a chemical change. A chemical reaction occurs. We cannot go backwards with this. It is irreversible. And the second picture is burning magnesium. We cannot go back and get magnesium after we have burned it. It creates a new compound called magnesium oxide. So there are 4 signs of chemical reactions. There's actually another one, number 5, I'll tell you about. Number one, color change. We combine two liquids and we get we see a change in color, which is a sign that a chemical reaction happened. You take two liquids and you combine them and a solid is formed. That is another sign of a chemical reaction. Bubbles. Seeing bubbles tells you that a chemical reaction happened. And energy. When energy is released during a chemical reaction, quite often you'll get light and heat. And that is a sign of a chemical reaction. So the fifth one is also a smell. Sometimes you can get a smell. This happens a lot with food that goes bad, it starts to spoil. That's a chemical reaction. And the sign that tells you the chemical reaction happened is that it smells bad. Alright, reactants. This is our last slide. The substances that take part in a chemical reaction. Now the reactants are on the left side of the arrow, and this is a chemical reaction here where hydrogen as a gas combines with oxygen as a gas, making water, and it changes from a gas to a liquid. What's made is called the product. So products are the new substances that are formed in chemical reactions. So that's it for today's video lecture. Please make sure you've written all your notes. I'll be checking them in class. Hope you learned something, and bye-bye. See you.